Hi. Recently I came across a couple of issues where people observed a very high CPU utilization on the fiber channel switches. And the main issue was that they were more or less overcommitting the monitoring efforts on their switches from an external point of view. So they were running multiple versions of external monitoring software, open source tools, commercial tools, external scripts, etc. In order to collect as much information from those switches in the entire environment as possible. The thing is that these switches are not really built to do just that. These switches are built to do fiber channel switching, and that's it. So they can provide you a lot of information from a traffic perspective, from a performance side, but they're not really very utilized with regards to a CPU grunt and the amount of memory, I/O capabilities, etc. So that's what they're not there for. So I made a short script in my lab to show you the implication of what's going to happen if you do that. If you drive the external calls too high. So let's have a look. So if you look in here, basically what we have here is on the bottom part, I'm logged in on the root account via SSH into a fiber channel switch. Now, normally there's not too much going on. So you will see that this is in a lab environment, so it's not really that that high. So there's not much change going on. Normally, if you see a lot of change in a fabric where where hosts going online, offline, you see in very large fabrics, you see name server distribution, and you see really daemons like the traffic daemon, for instance. Here, this is DMD, environment monitoring daemon. That's about it. So it's not really that much. So on the top hand side, as I said, I created a little utility which allows you to, which allows me, make it that, to have a look at if you overdrive these poles and these counters from a switch. So basically what I'm doing is I have a couple of parameters. So I can say, okay, the number of poles that I do to a switch is the number of occurrences. I use the SNMP walk tool in Linux to walk through an OID tree, and I can specify a timeout in here for each OID that's being queried in that MIM. Then the number of retries, and just in case it times out, if it passes that this particular parameter. Then I have the sleep time between each successive interval, because I can say, okay, between the number of occurrences I can have, I don't know, 10 seconds, or I can do 60 seconds, or 5 minutes, or 10 minutes. That's what I do here. And then the sleep time, sorry, the OID, I can put that in as well, but that's an optional parameter. So that being said, let's have a look. So the first one was let's say the interval, and let's put that into let's say 60 seconds. Then I have the sleep time, and I'm going to put that into let's say 30 seconds. Then I have the retries, I'm going to put that in 2 seconds, and then the timeouts, I'm going to put that 5 seconds. Then I put in the options, and I put that in all. So this is currently the IP address of the fiber channel switch in my lab, which is where I'm logged into on the bottom, as you can see. And that particular switch, that's a DCX8510 from Brocade. It has a couple of logical switches, logical fabrics configured. So basically the default is 128, and then I start from 40, 41, 42, 43, 44, and 45. So these are the 6 that I've configured in there. Sorry, 7. There are no F ports in 128. Neither is in 140, because 40 is the base switch. So it only functions as a backbone logical switch. But if you can see at the bottom now, there's not much going on. So the CPU usage is about 3%, which is fairly normal. So let's kill this off. And let's change the parameters a bit. So instead of 60 seconds in the sleep, so I do 60 iterations. So instead of a sleep time of 30 seconds, I do a I omit the all, and then let's still do this 30. So still the same. Number of fits. Let's see what's going on here. Okay, so as you can see, just for one iteration for the polling on the fits, it's doing 93%. So I think in the previous one it didn't accept the all parameters, so that's why it more or less killed off right away. But it's doing an S&P walk on the entire tree that's supported on that switch, which is basically what monitoring software does. So that's that's not new. So as you can see, it's still busy, still working on. So this is already the second iteration. So as you can see, it's constantly polling and polling and polling, and the CPU is constantly going through the roof. It's constantly over 80%. Now, what happens if that is sustained over a long period of time? You will also see that the default rules within, like for instance, maps, or if you have that licensed or configured, you will see that those events will also kick in. So you will get an event log that is used, that is showing a lot of high CPU utilization. At some stage, the memory usage will also grow. Now it also depends on the size of the environment, obviously, that you have, the number of blades, the number of ports, etc., that you have in this switch. Now this one is not really overly big, so I can show you what what it is. So this is basically switch 128, so the logical one. So there's not much going on here. The majority of, so these are the core blades, they don't have anything in them. Similar thing for, if you look at the, here you can see what I have in this particular one. So let's show you the model as well. So basically I have only one 48 port 16 gig blade sitting in that particular switch. So that's, it's not much in there. So basically what happened, but you can imagine if you, this is also an 8510-4. If you have an 8510-8, and this is one, and that one is fully populated with all 48 port 16 gig blades, you have an enormous amount of ports and SFPs sitting in that switch. If you then do an S&P walk over that entire install base in that particular switch, it will take a long time before all those values and all those counters from all those ports are being collected and being sent back. Now, some of the counters and values are being cached by the software sitting in the CP, so you might not get actual values. But if you start polling that particular switch, at some stage it needs to go out to the back end and over a management bus, which is then pulling the information from the different components, whether that's the fans, the power supplies, the SFPs, and some other real estate that's sitting in that switch. Excuse me. So that being said, it will give you a bit of an overview what this particular thing does. So as you can see, it is still busy doing the backend inventory, and you can still see the CPU utilization of that S&P daemon is very high. Now, if you overdrive that, obviously at some stage, as you can see, the nice value for the S&P daemon sits on 0, which is basically equal to some of the let's say more important daemons, like the traffic daemon. This is the FCP daemon. What else do we have? We have the traffic daemon, but there's also a zoning daemon sitting in there. There's a fabric daemon sitting in there. So if you have lots of changes in the fabric, and your S&P daemon is scheduling a hell of a lot of CPU time, some of the processes sitting in that switch, which have to start allocating thread time or CPU time via the kernel scheduler, may time out at some stage. It depends a bit on the queuing mechanism, but basically the name of the game is to only start monitoring and polling that those switches for the information that you absolutely need. So don't overdrive it, because as you can see, it may have a significant negative impact on your switch, and therefore some of the processes sitting in there, which then may have a further impact on the actual fiber channel switching that it needs to do. Because if, let's say, if an HBA is trying to log into a switch and it needs to register its ID and its capabilities into a name server, and that name server times out for just that purpose, that particular HBA or target port or whatever is not registered in the fabric, and therefore it cannot be reached by anyone, and so you don't have any data going on, no traffic. So let's go back and let's kill this this one off, and if all goes well, this needs to be terminated. So it's terminating the SNMP information right now, and as you can see, everything more or less returned back to normal. Now, that's a bit of the name of the game. That's a bit of the let's say the thing you need to take into account when you start managing and monitoring fiber channel switches. So you can monitor them, but only as a best practice, use one tool and one tool only. Use that tool well, and don't start getting creative with with writing scripts and things like that for getting information out of the switch. First of all, if you start a command like fos exec and then -- all, so for in all the logical switches that you have, and you do an SFP show, for instance, it might go out to all the SFPs on the back end. Now, the SFPs on the back end, they communicate over a very simple I2C bus. So Google on the web, or check Wikipedia or whatever, search for I2, so the number 2, and then C, so it stands for I2C, which is a very simple management bus. It's only a one-lane bus, which basically has an addressing schema, and each component on that bus needs to be collected, or needs to be inventoried, or addressed more or less individually. And thus, if you overdrive that, you're more or less locking up that bus, and you might see very strange results, especially when you have physical port state machines going back online, offline. You might see that certain commands coming from a fabric, coming from that CP might not even reach that SFP. So the laser will not get turned on, those ports might not get enabled. You have all sorts of different nasty stuff. So, that being said, if you have any more questions, just let me know and I'll be happy to answer them. Bye-bye.